guys. All right, today we are doing lesson 11.9. We're going to be continuing to talk about probability, but today we are talking about independent and dependent probability and those types of events. So we first need to know what's the difference between independent and dependent events. Well, two events are independent events if the occurrence of one event does not affect the probability of the occurrence of the other event. In other words, the events stand alone. They are independent. They do not affect each other. What happens in one event does not affect what would happen or the probability of what would happen in the second event. Two events are dependent if the occurrence of one event does affect the probability of the occurrence of the other event. Okay, so if they're linked, if the first event affects the probability of the second event, then we would call them dependent events. So let's start by trying to tell the difference between these types of events. Okay, so the first example is in a class of 30 students. A gym teacher randomly chooses a student for a demonstration. From the remaining students, the teacher randomly chooses another student. Okay, well, the key phrase here is from the remaining students. In other words, what we know is that in the first event, the first student chosen is getting chosen 1 out of 30. But then once that first student is chosen, there's only 29 students left. And so the probability of the second student getting chosen would in this case be 1 out of 29. So that probability of the second event has been affected by the first event. So these are dependent events. Okay? B. You roll a number cube or a dice, then you roll the number cube again. Well, these events would be independent because what you roll the first time is not going to affect the probability of what you roll a second time. It's not like you roll it and then that number can't be rolled again. So these two do not affect each other. Therefore, they are independent events. Why don't you pause the video and try C and D real quick. All right, so you randomly on C choose a numbered ball from the bowl, then you put it back in the bowl and randomly draw another ball from the bowl. All right, well, the key here is that you put it back, and because you put it back, these are independent events because what you drew the first time, since you put it back, is not going to affect the probability of what you draw the second time. D, however, says you randomly draw a marble from a bag. Then you draw a second marble without returning the first one. So these are dependent. We don't know how many marbles are in the bag, so we can't calculate the probability, but we know if, let's say, there were 10 marbles in the bag to start, that after you draw the first marble, there are only 9 marbles left, and so therefore it would affect that second probability of that event, and so these are dependent. All right, so we're going to first focus on finding the probability of independent events, so events that stand alone that do not affect the probability of each other. And if you remember from the other day when we did disjoint and overlapping, we were trying to find the probability of event A or event B happening, either or. And today when we find the probability of independent events, we are trying to find the probability of event A and event B happening, both of them happening. And so because we need both of them to happen, not just either or, we are going to be multiplying the probabilities today instead of adding them. Okay, so let's take a look at the first example. Each student in your class is to write a report on one of the first 13 states of the United States. Your teacher is allowing each state to be randomly chosen by more than one student. What is the probability that you and the student who sits next to you choose the same state? Okay, so because states are allowed to be chosen by more than one student, that's why these are independent. If the assignment was that each student had to pick a different one, that would be dependent. But because ones can be chosen more than once, this is independent. Okay, so again, because it's probability, notice we have our label It's the probability of the state and the same state getting chosen. So it doesn't really matter what the state is. Let's say, what's the probability you choose Massachusetts? Well, the probability that you choose it is 1 out of 13. The probability that the person next to you chooses it is also 1 out of 13. Okay, again, it doesn't matter which state it is, there's a 1 out of 13 chance that you would choose it. Okay, now we are multiplying these two fractions. So this is different than overlapping and disjoint. When it's independent, we multiply because we want both of these events to happen, not just one or the other. What is the probability that both of them will happen? Okay, so we don't have to have common denominators. In this case, we do, which is totally fine. That's no problem at all. Remember, when we multiply, we are allowed to cross simplify, which here we don't have anything. So we're going to multiply across the top. 1 times 1 is 1. And then along the bottom, 13 times 13 is 169. So the probability that you both pick the same state would be 1 out of 169. Again, you don't need to write that sentence at the end as long as you've put your label at the beginning and then have a simplified fraction at the end. All right, let's practice a couple more where we are calculating the independent probabilities of events. Number 1, a computer randomly generates 4-digit passwords. Each digit can be used more than once. That's what makes it independent, that you can choose the same one more than once. What is the probability that the first 2 digits of your password are both 1? All right, so since it's probability, I put my label at the beginning. This is the probability of generating a 1 and a 1 again. Again, the key word there is and instead of or today. All right, well, I need to know how many possible digits are there. Well, the digits could go from 0 to 9. So there are 10 possible digits that I could choose. And obviously a 1 would be 1 out of those 10. So the first digit, being a 1, would be a 1 out of 10 chance. Then I'm multiplying the probabilities here. And the probability that the second one is a 1 is also a 1 out of 10. So when I multiply those two probabilities, I get 1 over 100, which is in simplest form. And again, I have my label already at the beginning. So why don't you pause the video right now and try number 2. When you're ready to check your answer, press play again. All right, so in this problem, you were looking for the probability of rolling a 5 and then an even. So both of those events happening on your 2 rolls. So the first probability of rolling a 5 would be a 1 out of 6 because there's 6 possible numbers you could roll. I'm going to multiply that by the probability of rolling an even number, which is 3 out of 6. Now again, I'm multiplying fractions, so you are allowed to cross simplify. You want your answer to be in simplest form, so you could either multiply across and then simplify, or you could cross simplify and then multiply. I chose to cross simplify first. So 3 goes into 3 once and into 6 twice. And so then when I multiply across the top, I have 1 times 1, which is 1, and 2 times 6, which is 12. So the correct answer would be 1 over 12. All right, now let's take a look at the probability of dependent events. Remember, these are events where the probability of the first event is going to affect the probability of the second event, okay? So we are still multiplying these fractions or probabilities because we are still looking for the probability of A and B happening. But now, because these are dependent, you're going to find the probability of event A, but then you have to find the probability of event B given that A happened, and meaning assuming that A happened, because in order for them both to happen, obviously A has to happen. And so the probability of B is going to be affected by A. I think through an example you might understand this a little better. So in a box of 15 parts, 4 of the parts are defective. You randomly choose a part. Then you randomly draw a second part without replacing the first part. That's what makes it dependent. Find the probability that both parts are defective. All right, so they've already given the label for you. It's the probability that it's defective and then defective. So our first probability is the probability that the first part is defective, which would be a 4 out of 15 chance or probability, okay? Because there are 4 defective parts in a box of 15 total. Now, here's where it gets a little bit tricky. You are going to multiply that by the probability that the second part you pick is defective, assuming that the first part that you picked was defective, okay? Because if both events need to happen, then you have to assume that the first part was defective. So now, instead of 4 defective parts in my box, there are only 3, because 1 got chosen in the first event. And instead of 15 total parts, now there are only 14, because again, 1 got chosen in that first event. And because these events are linked, event B is dependent on event A. We have to assume that event A happened. That defective part got chosen and it was not replaced. Okay, now again, I'm multiplying these fractions. I think it would be easiest to do some cross simplifying first. So 3 goes into 3 once and into 15 5 times. 2 goes into 4 twice and into 14 7 times. And so now when I multiply across the top, I have 2 times 1, which is 2. And along the bottom, 5 times 7 is 35. That's in simplest form, so that would be my final answer. That's the probability that both of the parts are defective. Okay, let's try another one. A jar of jelly beans containing 50 red jelly beans, 45 yellow jelly beans, and 30 green jelly beans. You reach into the jar and randomly select a jelly bean. Then you select another one without putting the first jelly bean back. Again, that's what makes them dependent, is that you're not replacing it. What is the probability that you draw 2 red jelly beans? Okay, well, the probability of red and red. Okay, well, the probability that the first one is red would be 50 out of 125. Again, I added 50, 45, and 30 to get that 125. Now, the second probability, I am assuming that the first one that I chose was red. So now instead of 50 red jelly beans, there's only 49. And instead of 125 total jelly beans, there is only 124, okay? Now, I've got sort of big numbers here, so I'm gonna try to do some simplifying here to make these numbers a little bit more manageable, okay? I know that 2 goes into both 50 and 124. It goes into 50 25 times and into 124 62 times. And then if you remember, we can simplify across. You can also simplify a fraction, obviously, like the top and bottom. So as I look at that 25 over 125, I know that 25 goes into both of those. And so I can now say, well, 25 goes into 25 once and into 125 5 times. And that simplifies it even more for me. And again, you could have started by simplifying that fraction as well, either way. Okay, so now along the top I have 1 times 49, so that's just 49. And across the bottom I have 5 times 62. And again, you're welcome to use your calculator to make it go a little faster. That gives me 310. I can be sure that that can't be simplified anymore because I know that the only factors that go into 49 is 7, and 7 doesn't go into 310. So I know that that is in simplest form, so I'm good to go. All right, now before we move on to number 2, I want to talk a little bit more about some possibilities with number 1, because this is going to be on your homework sheet. You can find the probability of more than just 2 events. So for example, they could have asked you in number 1, the same jar of jelly beans, you pick one and then you don't put it back. What is the probability that you draw 3 red jelly beans? Okay, well, I'm going to come down below here. So I could take this as the probability of red and red and red again. And so this would be 50 over 125 like we had, times 49 over 124, and then we'd want another red one. So now there's only 48 left, and there's only 123 total. So it doesn't just have to be 2 events. You could have 3 or 4 or 5 events that you are finding the probability of, and you just would multiply each of those. Now again, this is going to get kind of big because these numbers are big and you'd have to do some cross simplifying, but you absolutely can do that. The other thing I want to point out to you is, let's say that this problem asked you to find the probability of red and then yellow. Okay, well, we've already found the probability of red. It's 50 over 125. Now, if you are assuming that the first one you chose was red and you want the second one to be yellow, well, there's 45 yellow jelly beans. And again, none of the yellow jelly beans have been taken. So there are still 45 yellow jelly beans, but one of the total jelly beans has been taken in that first event. So it would be 45 over 124 is the probability that the second one is yellow. So just make sure you're thinking about, if the first event happens, how does that affect the total number of whatever it is, jelly beans or parts that are marbles, whatever, that are left in your bag. Okay? Why don't you pause the video now and try number 2? When you're ready, press play again. All right, so in this one, you are trying to find the probability that both students who are selected are girls. So the probability that the first one is a girl would be 6 out of 13 because there are 13 total students. If the first one who's chosen is a girl, then there's only 5 girls left, and there's only 12 total students left because, again, one child has been chosen. And then I did a little cross simplifying and ended up with 5 over 26. As always, make sure that your probabilities are always in simplest form. All right, that's all for today. Have a great day.